Okay, a driveway has a 15% grade. What is the angle of elevation of the driveway? So here we've got that grade problem again. And remember, grade is a rise over run. So I'm just going to draw this driveway. Okay, and it has a grade of 15 for a rise and 100 for a run. And that's because the grade is equal to 15%. 15% is 0.15, which is equal to 15 over 100. And grade is rise over run. So your rise is 15 and your run is 100. I'm going to be able to find the angle of elevation. So here I've got an angle of elevation. I'll be able to find that angle of elevation of the driveway. And I can do that using tangent because I know the opposite and the adjacent side. So the tangent of x degrees is equal to 15 over 100. In order to find the angle, I'm going to have to put the ratio into the tangent function. So I'm going to have to use inverse tangent of 15 over 100 is equal to x degrees. And when I put that into my calculator, when you put that into your calculator, you get something like 8.53076561, and it keeps going actually. It stops on your screen because it can't keep scrolling, but that keeps going forever. So we say that it's approximately 8.5 degrees, right? So we say, okay, well, the angle of elevation is about 8.5 degrees. Now use that to find that if the driveway is 12 meters long, how much does it rise? So now if the driveway is only 12 meters long, let's just say that this is 12 meters. So now I'm going to use similar triangles, right, to find this rise or this height of the driveway, right? So I've got opposite and hypotenuse. Opposite and hypotenuse is your sine function. So the sine of now 8.5 degrees. Now many of us might just put in 8.5 degrees is equal to h over 12. However, this was rounded. And remember, we stored values. So you can store that value. You can store this. If you haven't touched your calculator yet, you can still store this as alpha A. So you can store it as A. And then I'm going to multiply both sides by 12. 12 times the sine of that stored value of A is equal to H. And when we get our calculator all done with that, you should get an answer of about 1.780085,435, which is about 1.8 meters. So the height or the rise is the rise of the driveway. So your change in elevation from the beginning of the driveway to the end of the driveway will be 1.8 meters. It's pretty cool. Pretty cool how that grade keeps coming back to us in problems. Okay, here's a problem. A toboggan travels from point A to the top, at the top of the hill, to point B. So here's point B at the bottom. It's going to travel down the hill. Because the steepness of the hill varies, the angle of depression from A to B, so the angle of depression from A to B, is only an approximate measure of the hill steepness. We can, however, think of this angle of depression as representing the average steepness. So if the toboggan travels 130 meters from A to B, the vertical descent from A to C is 50 meters. What's the approximate angle of depression? So I'm going to let you work this out. Come on back and you'll see the answer. So welcome back. So here I've made a pretty drawing. So here I've reproduced the drawing for us to mark all up. My angle of depression is the same thing as my angle of elevation from B to A. Opposite hypotenuse, so we're using the sine function. So the sine of angle B is equal to 50 over 130. And then the inverse sine of 50 over 130 is equal to, put that into my handy dandy calculator, inverse sine of 15 over 130. I can also say 5 over 13. And that is about 6.625, 6.625,809,565. I want to make sure that you've got the same numbers I do. So I'm going to say approximately 6.6 degrees. Now, why would this angle be approximately 6.6 degrees? Why is this angle of depression approximately 6.6 degrees? Well, you can see that the steepness is changing. So here we're steep, and then here we're not as steep. And then here we're just as steep, and then we're not as steep. So depending on what point we're at, you know, that first dip, let me erase this, that first dip is a steep dip, right? But then look at this next dip. That one's not as steep. And then this one, pretty steep again. And then the next one, not as steep. So what's happening is that we're just going to take an average steepness. So it's an approximate 6.6 degrees over the course of the entire 130 meter travel. So if you've got that, you should be good to go with the word problems coming up in the practice. Make sure you get that practice, because word problems, they're all around us. That's how we make sense of why we're doing the math we're doing. Shows us where we're going to use this in the real world.